All right, so here is the highly touted and anticipated homework help video, all right, that I know some of you are watching. I think enough of you watch it regularly that I should get a list of your names and like give shout outs or something, but we won't do that. So let's get started here. So our first problem, we're going to do problems 1 and problem 4. And so on our first problem, it says Carissa bought a new SUV for $30,000. That's pretty cheap, actually, for today's market, which is sad, but some of them are much more. Every year, the SUV loses 15% of its value. Write an exponential function that describes the value of the SUV T years after it was purchased. So that, again, is our general equation for this. So A is going to be, I'm going to write that up here, A is going to be 30,000, so that's our initial value, all right? And our rate is 15%, right? So if it's 15%, we move that decimal 2 spots, so that is 0.15. And so the general equation is y equals this 30,000 times 1 minus 0.15 to the t, and we're using t because they use t in the question, and then just simplify that inner part. So 1 minus 0.15 is 0.85 to the t power. All right, and now for letter B, when it says what's the value of the SUV in 10 years, keep in mind this is just an approximate because a lot of it has to deal with, you know, the history of the vehicle and how it was maintained and all that. But just a general kind of similar like blue book equation would be using this. So 30,000 times 0.85 to the 10th power. And my guess is that you're going to be a little, if you own this thing, you're going to be a little bummed at how little it's worth at this point. But welcome to the world of cars. They're a losing investment. So we take that, so 0.85 to the 10th power is 0.1968744, blah, 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 right, times 30,000, and you get a whopping, and we're talking about money, so we are going to round this to the nearest hundredth. So it would be $5,906. Yes, that's what I said, and 23 cents. So this thing in 10 years has lost literally 80% of its value, right? It's pretty sad, but that's actually pretty accurate. This is a real world problem in that sense. So $6,000, buy it for 30,000. 10 years later, it's worth $6,000. So that's how that works in the world of cars. Okay, so now let's move on to problem 4. And it says an adult takes 400 milligrams of ibuprofen. That is Advil for those of you who don't know. Every year, the body processes 29% of the ibuprofen in its system. How much ibuprofen is left in the system after 6 hours? And it's not every year, it's every hour, all right? So write our equation, right? Our A, so our initial amount is 400 milligrams, okay? And then our rate is 29%. So we're going to move our decimal over 2 spots. So you get 0.29 for the rate. So for my equation, we have y is equal to 400, which is my initial amount, right? And this is just, you know, for 1 day. And then 1 minus 0.29 to the to 6 hours, because that's what it wants to know. So we don't have to write a general equation this time. We can go right to what we're actually trying to find. So 400 times, well, 1 minus this is going to be 0.71 to the 6th power. And so let's figure out what that is. 0.71 raised to the 6th power is 0.128. And so you'll find that there's not that much left in the system after 6 hours, which makes sense because they tell you to take more after 6 hours. So it's saying at this point you have 51, and we'll go out just 1 decimal on this. I think that makes sense. 51.2 milligrams of ibuprofen remaining. All right, so that is where you're at with that problem. Hope these are helpful to you. Don't overthink them. Just use that formula, identify what A and R are right away, and then put them in and calculate. So have fun with these, and we'll see you at the next one.